Good afternoon and welcome. Thank you for joining our first FlyZero webinar. I'm Chris Gear, Project Director at FlyZero. For those of you who may not be familiar with FlyZero, it's a government-backed project led by the Aerospace Technology Institute. And our vision is to realize zero carbon emission commercial aviation by 2030. We're all about to protect our planet for future generations and meet our commitments to fight climate change. And we recognize we need a step change in the design, manufacture, and operation of commercial aircraft. This new breed of aircraft will call for entirely new design, engineering, and industrial capabilities, which will lay the foundations for the future of the industry. And it's just as investments made 40 to 50 years ago set up the aerospace industry we know today. Being at the leading edge of these new technologies is vital to the UK's future competitiveness in the global civil aerospace markets as international competition in this arena intensifies. This then is why FlyZero is taking a detailed and holistic look at the future of zero carbon aviation and the emissions that may need to be dealt with to try and get to a much better global environment. Our main focus is on the single aisle and the regional aircraft, which are operating between 1,500 nautical miles and 500 nautical miles. Throughout the project, we'll be looking at trade-offs as we consider the power to weight ratios, the range, the noise, the energy storage, the propulsion systems, configurations, and more. Alongside this, we'll be running cost models to ensure our concepts are economically viable in the future market. FlyZero will look to shape the future of global aviation with the intention of gearing up the UK to stand at the forefront of sustainable flight in design, manufacturing, and skills for years to come. FlyZero now has been going for about 4 months, and in that time we have grown from 4 people to 88 people. And we have built this team even though we're all in the COVID environment, and they are a really enthusiastic and interested team to solve this problem. And I really want to thank the contributors in terms of the organizations without whom this exciting mission wouldn't be possible. Airbus, Rolls-Royce, GKN Aerospace, Spirit Aerosystems, EasyJet, Reaction Engines, GE Aviation, Manufacturing Technology Center, Mott MacDonald, Belcam, and NATS. All of them have put secondees into FlyZero. And during today's events, you'll hear from some of the FlyZero leadership team on the work undertaken so far and what's coming up on our mission to revolutionize the future of sustainable aviation. Our speakers today are Naresh Kumar, Head of Sustainability, Mark Howard, Head of Commercial, David Debney, Chief Engineer, Whole Airframe Integration, Dr. Katie Milne, Head of Industrial Strategy, and Steve Newbury, the Academic Coordinator. They'll all come on in a minute and discuss and tell you their presentations. But just for some background, if you want to get involved with FlyZero, there are still ways to do that. We're still open to organizations of all sizes, both in and out of the aerospace sector. If you have knowledge and capability which supports our goals, we want to hear from you. We're clearly looking outside the norms of the aerospace sector. We're looking at other types of fuels, such as hydrogen and storage of hydrogen and ammonia. So we are looking to try and find some solutions to some of those hard questions. Today, we're launching our work packages, inviting organizations with specific expertise to tender for subcontract opportunities. And Katie will cover more of this later. Academic programs, putting research questions to academia to tap into the world's leading knowledge and research capabilities we have here in the UK. Again, we'll be offloading packages of work, and Steve will talk about those. And on the wider engagement, we're engaging with organizations through our extensive outreach program as part of our work to map UK capabilities. As part of today's events, we will have live Q&A, an opportunity to ask questions to any of our today's speakers. To submit a question, please can you scan the QR code on the webpage or visit sli.do and enter code 098956. So that's sli.do and enter code 098956. You can also join the conversation on Twitter using hashtag FlyZero. I'll now hand over to the first speaker this afternoon, Naresh Kumar, our Head of Sustainability.
Good afternoon. The effects of global warming have created a climate emergency that must be addressed by everyone worldwide. The science is clear. Detailed reports by the United Nations Intergovernmental Panel of Climate Change tell us that global warming leads to many catastrophic effects. More extreme weather, colder winters, more rainfall, hotter summers, etc. These are already affecting many regions of the world, from floods and droughts, with nations spending huge sums on adaptation. Problems for agriculture affect food chains and ultimately threatening the health of all forms of life. Aviation accounts for around 2% of man-made CO2 globally. This is over 800 million tons per year. It could be double this due to non-CO2 effects of aircraft emissions at altitude, including contrails that could lead to the formation of cirrus clouds. The UK proportion of this amounts to 37 million tons per year. However, as other sectors decarbonize, this percentage will increase significantly. So more action is needed now. This chart shows the proportion of CO2 generated by different size of aircraft. The concepts being evaluated by FlyZero are aimed at addressing the regional and single-aisle categories. These account for nearly 50% of emissions from aviation, so success for the program will have a huge benefit to reduce CO2. Global concern about climate change has led world leaders to agree to limit temperature rise below 2 degrees, with an aspiration to keep this below 1.5 degrees by the end of the century. The UK is amongst the leading nations to enshrine its commitment in law to achieve net zero greenhouse gas emissions by 2050. This was further strengthened 2 weeks ago when the Prime Minister announced that we will reduce emissions by 78% by 2035, 15 years sooner. Government policy is changing fast, and for the first time, international aviation has been included in the UK goals in the 6th carbon budget recommended by the Climate Change Committee. In response to this, industry has also set itself extremely challenging goals to reduce emissions and thereby contribute to government targets. Globally, by the International Air Transport Association and the Air Transport Action Group. Across Europe, by the Advisory Council for Aviation Research and Innovation, ACARI. And here in the UK, by the Sustainable Aviation Consortium. This is over and above standards that already exist and are set by the United Nations International Civil Aviation Organization, their Committee on Aviation Environment Protection, which already covers CO2 emissions, NOx emissions, noise, and air quality, etc. The aviation sector, like many others, has also been mapping its contribution to the United Nations Sustainable Development Goals. So overall, a very comprehensive landscape for tackling the climate emergency. So what does all this mean for FlyZero? In short, all emissions need to be addressed. We have set some really challenging targets for FlyZero concepts to meet when they enter service in 2030. Zero carbon emission is the core objective for the project, but We also seek to reduce NOx emissions by 25% to existing standards, halving particulate matter, and further reducing noise by 7 decibels to Chapter 14 standards that exist today and were agreed back in 2017. Regarding water emissions, we are exploring technology solutions that many enable contrail avoidance. We plan to undertake a full life cycle analysis, and given that well over 80% of aviation emissions stem from the use of the aircraft in service compared with manufacturing, test, servicing and end-of-life considerations, the choice of fuel or energy source becomes fundamental. So we're looking at batteries, hybrids, hydrogen, ammonia, and fuel cells. Adding these emissions inventories into a life cycle analysis model at an aircraft level and fleet level will enable us to compare different concepts and help us to down select the most promising configurations to minimize the overall emissions footprint. Clearly, in addition to sustainability, we will also review the technical, commercial and industrial aspects. The prize is enormous. A very rough calculation indicates that FlyZero concepts entering service in 2030 could help to reduce CO2 by 2 gigatons by 2050. So in summary, we want to get to a solution where FlyZero concepts are not only sustainable, but manufacturable, marketable, and of course affordable, so as to enable society to carry on and benefit from air travel guilt-free. Thank you.
Good afternoon. My name is Mark Howard. I'm Head of Commercial Strategy for the FlyZero project, and I'm seconded from Airbus. FlyZero will be developing and validating our own demand forecasts, but of course informed by industry. What you can see on the chart in front of you is a measure of revenue passenger kilometres in billions, you can see, against time. And the forecast that we've shown here on the screen has the Airbus forecast, which was a 2019 forecast pre-COVID, of course, the Boeing forecast, which was updated in October 2020, and and actually that only had 2 spot points, 2029 and 2039, and an IATA forecast, which IATA have regularly published updates in terms of a short-term COVID recovery forecast, and you can see that their expectation is that traffic will come back to 2019 levels in around about sort of 2024. The expectation is that the traffic, obviously, as you can see from the chart, will increase in terms of numbers of people wanting to fly, which ultimately puts ever more pressure on the industry to find sustainable ways of flying. Turn to the point of what are the target markets to maximise our sustainable future that we all want for aviation. These charts are portraying the numbers of seats against range per aircraft, and what you can see is actually globally the short-haul and regional operations represent actually 91% of flights and 55% of available seat kilometres, whilst the wide body operations actually only are 9% of the flights, however 45% of the available seat kilometres. What's been interesting is if we look back to 2004, the growth in aircraft demand has been absolutely dominated by the narrow body aircraft types, and actually representing 92% of the total growth, and that's the A320 737 type aircraft. And actually also within that sector, for those short haul routes, we've actually seen a demand for more aircraft seats per aircraft, typically about a 32% increase, and the sector length, so the flight range, the duration, has increased by 24% over the last 15 years. So ultimately, more people flying further. If we then turn to the wide-body twins, and we can look at that has also increased in terms of market growth slightly, but that's driven both by market growth itself and also replacement of 3 or 4 engined aircraft. So we then, that more modest growth is also matched by a more modest growth in aircraft size, so typically about 9% more seats, but again more significantly people flying longer sectors. So typically around about 30% increase in terms of sector length, flight duration. So I guess the takeaway from this slide is that the focus that we believe needs to be made is on the short-haul market, and that will be our initial priority. Of course, FlyZero has got a strong ambition to work with the wider ecosystem, making sure that we can engage with the airlines and the airports to make sure that we can integrate their requirements. Of course, not forgetting the airspace management organisations as well, and of course some of the regulatory bodies. What we've got to make sure is that whatever a FlyZero type aircraft looks like, it can be integrated into that airline, that airport, that airspace, making sure that the aircraft is not only sustainable but also productive in its operation. We also need to consider things like the regulatory bodies to make sure that all the new rules are set, to make sure that that safe and efficient turnaround can be made in as efficient a way as possible as it would be today with any conventional commercial aircraft. Of course, we also need to look at the energy and the infrastructure that's required to make sure that the new fuels that are generated can be supplied to the airport, can be provided to the aircraft on time, at the right volume, at the right cost. We need to make sure we can balance the sustainability with the operating economics to make sure we can meet the market demand in a very sustainable way. What I'd like to do now is focus on one of those ecosystem elements, the airport infrastructure, and take you through an example. We're going to focus in on hydrogen as one of those obvious fuels to support the zero carbon future that we absolutely need. Whilst our focus is on the airport and the airline requirements, we cannot ignore the supply of these new and alternative energy sources to meet those airport needs and to meet that flying demand. And the infrastructure around the airport obviously needs some very, very strong consideration. So what I'd like to do is just quickly take you through this chart. The picture in front shows sort of 3 potential futures. One is the top line is a limited distribution network whereby there'll be low aircraft demand and there'll be a road and rail transport network to deliver the likes of liquid hydrogen to the airport and to the aircraft. That would be okay for, as it says, low demand. Very feasible, demonstrated today in the US for the space program. The middle line is maybe a much higher frequency of aircraft demand, but without a network, a national network of distribution of that energy, in which case you'd have to generate that energy on that hydrogen on site, and which comes with its own significant challenges, space, etc. And of course the bottom line is then looking at, if we have high demand but you also have a distribution network, then you can do that generation off site. You potentially could then pipe the hydrogen through a distributed pipeline like natural gas is distributed today, and then liquefied on site for uptake on the aeroplane. So some different options here, but very dependent upon ultimately a national strategy in effect, in terms of what is the national strategy for the UK on this specific topic or example or challenge of hydrogen. Now we know that the road, particularly heavy goods, marine industry, rail, all looking at the opportunities of hydrogen, along with also, of course, domestic heating as another prime example. The amount of demand ultimately then defines the supply and the ability to supply in any one of these different routes to deliver this new zero carbon energy source. So one of our plans here is to, as I said, reach out to some of these organisations, and we've already mentioned we're talking to a number of airports, to look at maybe some feasibility studies, some case type studies, to see what those, understand much deeper what those challenges are. We will of course be looking into the airline, airport and airspace operational challenges in a very integrated way, because it's quite clear to us that you cannot divide or silo them. What has been really clear when we've been talking to a number of stakeholders in this arena is that what they want is a view of the future. They want to understand what sustainable operations means to them. Now what we can do is we can divide the operation into ground and flight operations, and those operations are underpinned already today by the so-called airport collaborative decision-making mechanism, which ultimately looks at the planning and execution of all the activities related to the aircraft's flight and airports operations. We've already talked about the fuel supply and the need to ensure and secure that fuel supply, but we'll also be looking to work through the processes of fueling, turnaround time and safety regulations. What's clear is we need both a safe but also efficient turnaround, and we're looking into that at the moment. And then turning to excuse me, overall sustainable operations, we will be of course looking at air traffic management and looking at topics such as contrail avoidance, making sure that we address the potential warming effect that contrails have, but also looking at how we can maximise and manage that airspace capacity if we are taking the avoidance actions. And we'll also be of course looking at new technologies, the ideas around optimum flight trajectories, how we can use those for improving time, noise and fuel savings. And ultimately looking at that sort of ATM of the future, and what does that mean for all these newer users and new rules effectively which could emerge as a consequence of sustainable flying. And of course we will be looking at airspace and airport capacity issues that are highly dependent upon aircraft performance characteristics, and we will be working as an integrated team with the guys who are looking at the aircraft design to make sure we understand what recommendations are to ensure that we can maximise the airport and the airspace capacity. So I'd just like to sum up on the topic of meeting market demands. So FlyZero is clearly targeting the primary addressable markets, looking to ensure we maximise the impact on carbon and emissions reduction. We're of course looking at the economic and the environmental case through both of those lenses to understand that we can size the challenge that we have ahead of us. What we can say is we do know that investments will be required by many stakeholders, be that the airlines, the airports, the aerospace manufacturers, but also governments, to make sure that the right infrastructure is in place to support the entire network. Of course, beyond developing the specific technologies for the aircraft and also the aircraft itself, there's clearly an urgency on understanding the challenge related to zero carbon fuels and the energy and infrastructure required to deliver them. There's obviously clearly a role for policy to play here to encourage the take-up of new zero carbon technology, And this clearly cannot be done by one country alone. The UK cannot be standalone on this. There has to be a global movement. But what the UK can do is use its influence to set a very strong example. So as we've said, what we're looking to do is engage strongly with the aerospace and aviation sectors, and ultimately want to make sure that our stakeholders, what they clearly want to have is an informed view of what that future will bring. And our engagement is looking to partner and maybe even establish some use cases to fully understand and portray those challenges that we have in front of us. What we know is there's a revolution in sustainable air travel coming, and that will bring new demands and new opportunities. So maybe I'll leave you with a quote from Winston Churchill: "You should never let a good crisis go to waste." So thank you for listening, and I look forward to taking your questions later.
Good afternoon. I'm here to talk to you about the technology aspects of FlyZero and how we're really trying to push the limits and not just come up with the same answer that others have already published. This involves looking at a whole range of aspects in terms of the problem, and I'll explain some of that as we go through my presentation. My name is Dave Debney, and I'm the Chief Engineer for Whole Aircraft Integration. I'm actually one of 4 Chief Engineers on this project, and it's important that I recognise their contribution as part of this presentation. Joining me are Tim Goldsworthy, who's the Chief Engineer for Airframe, Mark Willier, also the Chief Engineer for Airframe, and Simon Webb, the Chief Engineer for Propulsion. And of course, there is a wider team looking at the technology aspect of the problem, all working hard to try and help our understanding. So firstly, I thought I'd start by talking about the FlyZero approach to innovation. This is something that people often overlook when they're addressing these kind of problems, but how you take a structured approach to coming up with new ideas and using them can be incredibly important to how the solution comes out. First of all, FlyZero as an overall problem is too big to attack in one go. The idea is that you break the overall problem down into smaller chunks and use that to come up with different ideas and then see how they combine. So the picture is intended to illustrate exactly that approach. We pull out specific questions and we put them to the team and we think about what those answers might be, and then you integrate it all back together to look at where the overall solution might go. There are many examples of innovation in aviation's history, but it's really important to stress that we are also looking at innovative examples outside of aviation where we can also learn a huge amount. Some examples of coming up on the slide now. Tesla, for example, I'm sure most of you have heard of them. The key innovation that I think they made was realizing that the charging infrastructure was going to be crucial, but actually going out and doing something about it. The ventilator challenge was an excellent example of multiple stakeholders coming together to address an unfamiliar challenge and really make some progress in a short space of time when the country needed it. The America's Cup is an obvious example of a different sector and pushing the boundaries of innovation. Certainly, I don't think we would have expected to see boats travelling as fast as they have done in the recent competition. SpaceX is another good example. Even 5 or 10 years ago, it would have been very unusual to think of a private company putting people into space in a way that had previously been the preserve of governments. Something coming from a different perspective, Spotify, completely changing the way that the music industry works and uses the different platforms available to it to get different products out there. And in the bottom left, a Formula One pit stop. So actually what we're doing here is a current challenge around turnaround time for aircraft and how different energy sources may change this, and starting to think about, can we take some inspiration from something like a Formula One pit stop in terms of how thinking about the problem and how we address what some of those challenges may be. So in terms of what this actually means for FlyZero and the approach we're taking, you can see here we have been using some tools in terms of collaboration where individual team members can contribute at the same time to the same screen, all at the same time. And that means that it's really great for having diverse ideas and free thinking. My personal view is it's still not quite the same as having everybody in the same room, but it's pretty good. And as you can see, we are coming up with some multiple ideas and lots of different approaches. More recently, we've been taking a slightly more structured approach in terms of the Microsoft Teams app has an ideas function within it. Other equivalents are available. And what that enables us to do is for individuals in the team to contribute ideas and others to comment on those, work collaboratively, vote for what they feel are good ideas. And that structure, especially when we're all working remotely, just means that it gives us an extra edge in terms of recording the ideas and making sure that we don't miss anything. So far, we've generated loads of different ideas and we've launched a series of challenges as a result. So those challenges have been looking in the main at different aspects of what we're calling the technology bricks. What we see is these technology bricks building up to make the backbone of FlyZero and the solution that goes forward. For us, actually, this project is more about the technologies, and the concepts that we'll talk about later are really the means to show what these technologies can do when combined together. As you'd expect, we've done many different studies and sprints looking at things like hydrogen storage and distribution. Ammonia is another area that we're looking at. So we looked to identify the key different options in terms of zero carbon fuels and what they might mean. Ammonia cracking is listed there because one of the options that we're looking at is having ammonia as the fuel in the tank, but cracking that ammonia to use a blend of hydrogen and ammonia from a combustion perspective in a gas turbine or other combustion system. Cryogenics are required because we think hydrogen may need to be in a liquid format, although it could also be gaseous, and that's something we're looking at. If it's in its liquid form, it needs to be at minus 253 degrees centigrade. So that clearly requires some specific engineering of the system. That then ties into some novel fuel systems in gas turbines, which we're also looking to understand what that impact might be. Will it affect the efficiency? Fluid and thermal management then ties hand in hand with that, especially if you've got cryogenic systems on board. That also could mean that you have different fluids that can take different levels of heat to help manage that overall system. I'm going to move to the next row now and look at batteries. So batteries are a very interesting option because they're genuinely zero emission in operation. Unfortunately, the current technology levels are such that for the levels of power and energy that a commercially sized aircraft would need, they don't really meet the requirement. There are roadmaps that show how those will improve over time, but in the 2030 timescales that we're setting ourselves in FlyZero, we don't think that they're going to quite be good enough to get to that primary energy source requirement. However, that doesn't mean we can't look to use batteries in secondary systems and the overall power systems of the aircraft in an innovative way. Fuel cells are another option for using hydrogen. We're also looking at those in combination with other systems, whether it be batteries, whether it be gas turbines, whether it be other combustion engines, and how that could work. High voltage electronics then come with the territory as soon as you're introducing high voltage electrical systems in order to make sure that we can get the power and the energy from where it's produced to where it needs to be used on the aircraft. Electrical machines sit alongside gas turbines as our route to thrust generation, so turning things into kinetic energy. The powertrain and things like power gearboxes are all part of that. So there's an example of Rolls-Royce doing the UltraFan program, which has a power gearbox. You may also need gearboxes to change the speed output from an electrical machine before it goes into a propeller. That leads neatly into thrust generation. Now here we're looking at how you actually generate thrust on the aircraft. That could be a propeller, it could be a ducted fan, or it could be the fan in a gas turbine. All of these different options have relative pros and cons that we're examining and may lend themselves to some of the other different energy systems and propulsion systems that we've discussed. Landing gear is also an important consideration. Some of the options that we're looking at could significantly change the weight of the aircraft, both in terms of overall weight at max takeoff weight, but also potentially max landing weight. So in systems where fuel doesn't burn off during the flight, that may well change the requirements on your landing gear. And as you go up in size of the aircraft, that becomes a bigger problem relative to the systems that we have today. Handling and stability is an interesting one. If you go to a different wing shape, or if you change the shape of the aircraft because you feel that that's a better way of integrating some of your novel energy systems, you need to consider what impact that will have on the handling and how you might affect control, so things like ailerons and flaps. Airframe integration ultimately wraps a lot of these things together, and you need to think about, for any given technology, what impact will it have on the airframe and the aircraft when you integrate it together as a system. We're also looking at a range of technologies in other areas. So we've got some underpinning technologies shown here, such as materials. So materials such as using carbon fiber to make hydrogen storage tanks. Life cycle management. What do you do with a concept aircraft when it comes to its retirement? Can you recycle most of the materials? If you consider that at the start, might you choose different materials even if it had a slight impact on performance? These are all trades that we're looking at as we go through this project. Compressed design and validation is another interesting one, given that we've set ourselves the ambitious goal of getting something into service in 2030. And then, of course, emissions impact modelling, which Naresh has covered in his sustainability presentation. Leading on from my colleague Mark Howard, we're also looking at the technologies and on the aircraft and how they tie into operational technologies, such as what does an alternative fuel supply at the airport actually mean, both in terms of how the aircraft is refueled, but what does it mean for airport infrastructure and how fuel is stored. So this is an overall summary of the technology bricks that we're looking at in FlyZero. We've done a range of studies on different aspects of the problem so far, and now we're looking to take the learning from that and apply it into our own concepts and scouts, which I'll talk about shortly. So how do we create scouts? So firstly, what is a scout? So what we are calling a scout is an aircraft definition that we have defined to take a combination of particular features, which could be energy sources, it could be architectural features on the aircraft like position of wings or overall configuration such as a blended wing body. And what we've done is we've defined a series of scouts in order to learn the most from studying those different feature combinations to look at what impact they might have. Now clearly there are some key initial decisions you need to make when defining those scouts, like is the primary energy source hydrogen, or is it electric, or is it something else? So these are some of the challenges that we're wrestling with at the moment. Now clearly FlyZero doesn't exist in a bubble, and we need to be aware of other activities that are going on around the world, and where possible learning lessons from those projects. So a few examples are shown here. The DLR HY4, which is a hydrogen aircraft, the Heart ES-19, a battery-powered aircraft, and the NASA Sugar, which was looking at more conventional propulsion, but how it could be made ultra high efficiency. We've also come up with some innovative approaches and brought in some young talent to help us design some concepts. So here I'm showing two Lego concepts that one of our youngest designers, aged 7, came up with. A blended wing body with large winglets and a very high aspect ratio wing with rear engines made out of Lego. We actually do have a huge amount of creativity and talent in the team, illustrated by some of the sketches that I'm showing on this page. The scouts, as I say, are not designed to be taken forward in their current form. The scouts are designed to help us learn. And what we will do is we will take that learning and move it forward into creating some concepts that will form the second half of the FlyZero project, when we go and look at a small number of concepts in more detail. So how do we get from creating these scouts, which are the initial ideas that we're starting to study now, to creating those concepts? So to give you an idea, we're currently at about 15 different scouts, and it may end up increasing from there depending on the ideas generation that we get from the team. But we're aiming to get down to 2 or 3 concepts to take forward in the second half of the programme. Well, the way we do that is we take the scouts and we look at the requirements of the project and then the aircraft and combine those two things. So what I'd like to do is take a step back for a second and look at what those overall requirements and objectives are. So on the slide I'm showing the top 6 objectives that we've set ourselves for this project. Creating aerospace value is the reason that FlyZero exists, as well as making sure that we can make a sustainability impact on the aviation sector. Not just creating a new part or decarbonising some of it, but maximising the sustainability impact on overall aviation emissions. As a result of that, we need to make sure that we maximise the addressable market potential. Otherwise, we can't hope to achieve a significant impact on overall emissions. We're aiming to create some world-class concepts, and actually we need to make sure that we consider safety from the beginning. Introducing new technology doesn't mean that we can impact the level of safety, and we need it to be at least as good as current standards. And of course, with the ambitious programme that we've got, we need to make sure we define what the next steps are following the FlyZero project. So what I'd like to do is take a couple of these overall objectives for the project and look at how we've turned those into aircraft requirements. So starting with sustainability, we're very clear that on FlyZero our goal is 0 carbon, and that's non-negotiable. So any ideas at the moment that are not 0 carbon have been parked for the time being. That doesn't mean we've forgotten about them when they are being recorded, but that's the fundamental goal of the project. Having said that, if you have an idea or a concept that is 0 carbon but 3 times as noisy, or massively increases the NOx output, or contrail formation, based on the latest science that we're looking at, that doesn't actually help us in reaching our goal of minimising the overall climate impact of aviation. So we need to aim to minimise all of the different impacts. So things like non-CO2, but also noise. That's one of the biggest areas where, you know, the general public interacts with aviation, and we need to make sure that we're factoring that into the designs that we're coming up with. If your aircraft ends up being heavier, for example, that is likely to introduce a noise challenge, and so that's one of the key areas that we're looking at the moment. We're also going to target specific markets with our concepts, and that ensures that we can aim to get specific requirements for the aircraft and maximise the addressable market potential. So that's interrelated with the next objective. And finally, we're aiming to enter into service in 2030. But rather than simply saying, where do we think things will get to based on their current trajectory, actually we need to turn the question around and ask it the other way and say, what is required to get technology at the level we need by 2030? That could be investment, that could be collaborative projects, it could be a whole range of things. But the important message is that we're turning the question on its head and saying that that's the deadline. What can we do in order to meet it? Not simply settling for the fact that things may drift into the future. Next, I'd like to look at the FlyZero concepts themselves. So we say we want them to be world-class, but what do we mean by that? So in terms of the requirements for the concepts, we want to create a vision for the future and a tangible path to get there. So we need to demonstrate that the concept that we've come up with has a logical conclusion as to why we think that is a sensible answer and provides something that meets both the aircraft objectives and the overall project objectives. But it's got to be something that's tangible. Leading on from that, we need to make sure that the concepts are viable in terms of development, purchase and operational costs. So we're setting ourselves targets based on these requirements to try and make sure that we're coming up with sensible ideas and making sure that it will fit within the market. We don't know what the future will hold, but what we do know is that if new technology and solutions are prohibitively expensive, they will have a much harder time breaking into the market. And finally, we're coming up with a clean sheet aircraft design. And so it's an excellent opportunity to try and improve the passenger experience. That's an objective rather than a requirement, but it is something that we're factoring in as we go through the process. So just to revisit some of the key points that I've talked about today, in terms of the technology team and the FlyZero team overall, we've firmly established zero carbon emissions as the requirement for FlyZero, as the primary requirement for FlyZero. Time is critical. That's why we're pushing forward as fast as we can. Competitors around the world are pushing ahead, and that's why we need to set ourselves the ambitious goal of being in service in 2030. We have a diverse team drawn from across the UK, which is one of its key strengths. The diversity of talent and ideas is already apparent in the input that we've had, and that is crucial to coming up with the best overall solution. We're investigating a range of technology bricks in a range of different areas, both on board the aircraft and in terms of underpinning technologies and operational technologies. We've generated an initial set of scout aircraft, and these will lead to some concept aircraft as we go through the process to illustrate what is possible. So what we're doing now is going into a multidisciplinary phase to assess these different scouts, their combination of features and the technology building blocks that go into them. We'll use those and combine them with the aircraft objectives to produce some concepts in a few months' time, which we will then go and continue to investigate further as the project progresses. So we've made some great progress so far. We've come up with some really interesting ideas that we need to go and look at further, and we will continue to push hard to come up with a vision for the future that we can brief out to the UK that illustrates benefit for the UK in terms of technologies and what they can achieve. I'm now going to hand over to the next presentation. Thank you very much for your time.
Hello, my name is Katie Milne and I'm the Head of Industrial Strategy for FlyZero. I'm going to give you a very brief overview of how we are approaching the industrial strategy in the FlyZero programme, but the main focus of this talk is to talk to you about how you can engage with FlyZero or how you can be part of it. So for me, the industrial strategy boils very simply down to where we are now, where we want to get to, or what the opportunity is, and how we're going to bridge the gap in between where we are now and where we want to get to. We use the word capability that you can see at the top of that slide to cover technology readiness, but also infrastructure, skills, factories and supply chain capability. And roadmaps is the word that we use to talk about how we're going to get from our current state to the future state, our objective. Earlier, David Debney was talking about the different technology areas that we're looking at on aircraft technologies, underpinning operations technologies. Here we've identified 24 different technology areas, and my team's working with engineering and in FlyZero and across the UK to understand what capability we've got in these different areas right now. In parallel to that, the engineering team are developing concepts combining some of these different technologies, and my team wants to understand what capability does the UK have to deliver against those concepts, what potential is there for UK to have work share on different concept types, and really where can we make the most benefit to CO2 reduction. Once we've done that assessment, our intention is that we do it consultatively and that we also take a very strong regional view across the regions of the UK. Then our intention is to publish a document which gives an overview of the UK capabilities and opportunities. The regional view in that document, we're hoping to be quite strong. We believe that different parts of the UK have different strengths, there's different clusters, and there's also different funding streams available in different parts of the UK, and we need to throw everything that we can at this mission. Around the aircraft, we'll be trying to map out which aircraft might come through and in what timeline. And we'll have an aircraft level development plan, and then below that we're going to have a number of roadmaps. On the left you see 24 different technology areas. That's a lot if we were to convert each one to roadmaps, but over the course of the project we expect some of them to be discounted, some of the technology areas to move or be consolidated, and so to accompany that development plan for the concept aircraft we're hoping to have about 6 to 10 roadmaps. Out of these will derive the strategic case for the United Kingdom, for public investment and for private investment, and our hope is that this will set the focus and the framework within which we carry out R&D on zero carbon flight for the next decade. So as I said, that regional view on capability is really important to us, and to make sure we get it, we're planning workshops across the UK nations and regions, and we're working with devolved administrations and also with aerospace trade and cluster bodies. So we've been talking to the Scottish Government, the Welsh Government, to NI Invest. We've been talking to the regional alliances, including the West of England Aerospace Forum, the Midlands Aerospace Alliance, and the Welsh Forum. And if I've not spoken to you yet, if my team hasn't spoken to you yet, we are coming, I promise, because it's an absolute priority for us. Our aims are to understand the current state of aerospace industry across the UK regions, especially post-COVID and post-Brexit, to identify regional capability and strengths relevant to zero carbon aviation, to obtain a view from industry and other stakeholders on what the UK could or should contribute to the global effort to achieve zero carbon aviation, and to find out what support we need to realise this. And then we want to understand also what each region could contribute to this effort. Okay, so that's the industrial strategy, and you can see that engagement and collaboration and consultation with industry is a really important part of its formation. The one thing I forgot to say was that we really want voices, not just from the incumbent aerospace industry, but from other sectors as well. And so we're going to be working really closely with the aerospace fora, but also hoping to work closely with other organisations across other sectors, particularly oil and gas, space, and automotive. Automotive is already quite far forward on its decarbonisation journey, and bring those people into the forums and the other kind of more central events that will run over the course of the year. In terms of other ways to get involved, I'm going to talk to you quite a lot for the rest of this session about work packages. FlyZero is inviting organisations of all sizes from across the UK with specialist expertise to tender for subcontracting opportunities across a range of areas, including energy storage, propulsion systems, airframe design and integration, commercial, industrial and sustainability. And I'm going to go through with you the work packages that we're prioritising at the moment. We're also running a broad programme of engagement with stakeholders to identify priorities for future activities, and I'll talk to you about that first. So in terms of events, I spoke to you about some of the aims of our regional workshops. Our intention is that we'll run those from late May all the way through to July, and possibly do a second round again in late August, September, October. And we're working hard to get dates in the diaries with our partners at the moment. We've also set up 3 forums, the FlyZero Airports Forum, the FlyZero Airlines Forum and the FlyZero Pilots Forum. We've already formed those groups, so we've got invites out. However, if you feel that you could really add something to the conversation and to the formation of our strategies, We're really interested in the wider ecosystem, because we see that as critical, for this to happen. Industry has to develop solutions, but the broader aviation sector has to put in infrastructure, and the two things are somewhat chicken and egg. So if you feel like you've got something to add on this mission, then please don't hesitate to get in touch. And finally, we'll be running quarterly FlyZero webinars like this one, with the next one planned in summer 2021. And our hope is that later in the year, or perhaps early in next year, we'll be able to meet as a community face to face and share the progress and outputs of the project. So in terms of dates that are already in the diary for you to look out for, on the 13th of May, we've got a members meeting with the Midlands Aerospace Alliance. We've also, as I said, had meetings already with the West of England Aerospace Forum and also with ADS Scotland, and we're keen to come and present at the other regional alliances around the UK. And Chris Gear, the project director, will be speaking at the Royal Aeronautical Society on the 10th of June. Please watch out for those other regional workshops as well, which should be advertised soon, and they'll be advertised by both our partners but also through the ATI LinkedIn channel. Okay, so work packages. Over the next 3 months, we'll be launching tenders for work packages on the FlyZero website, and you can see the address down there, ati.org.uk/FlyZero/work-packages. All the work's got to be completed this calendar year, and we're really aiming completion by September to November. Those 4 things that you can see are the first 4 to launch onto the website, and they're already live, but there'll be many more coming over the next couple of months, so please keep an eye out. If we think that a company has capability, obviously we'll also try to actively contact them, but we can't capture everybody, and so this is our attempt to make the process as open as possible. The work packages will cover areas where we need to bring in specialist expertise. There's also a very large range of options for zero carbon aviation in terms of both propulsion solutions, but also in terms of airframe solutions and aerodynamic improvements. We're determined that we use this opportunity on the FlyZero programme to carry out an independent assessment and to help the UK ultimately and the global community converge on solutions. So for that reason, we're looking at all options in FlyZero, and as an example, you can see up there that there's a work package that's gone out to carry out a feasibility assessment on zero carbon fuel internal combustion engines. We recognise that these may not compete as a primary propulsion system for large aircraft, but they could be an auxiliary solution, and so the purpose of the work package is to get that knowledge for the UK community. So other work packages, I'll go through these in 3 groups, so airframe, commercial and then propulsion. And then I want to highlight one particularly on propulsion, on cryogenic systems. So around airframe, we're interested in airframe technologies, including, for example, technologies that allow the wing to morph and shape. We're interested in how you integrate novel energy storage and propulsion systems into the airframe. We want to know about airframe noise capability and assessment, sustainable cabin design and technology, airframe materials, and then a through-life analysis of the aircraft and airframe. On commercial, we're interested in how you do a safe, and sorry if you can hear an aeroplane. I live on a flight path, so I'm very passionate about aviation and noise particularly. So on commercial, we have we're looking at safe or rapid turnaround, airport infrastructure requirements for new fuels, the aviation demand on the hydrogen supply, comparison of zero carbon aviation with other transportation modes, assessment of the public perception on zero carbon flight, and cost model development. You can see from that list that FlyZero is not just, and this has been said earlier, it's not just about the aircraft development. We are extremely clear that in order to progress, We need to have public buy-in. We need to have the aviation sector building infrastructure in order to allow aeroplanes to take off and land. And that needs to be in multiple locations. We can't have an aeroplane that takes off and lands in the same place. So this is a massive concerted aviation sector effort in order to hit zero carbon solutions in the future. On propulsion, which is one of the most critical areas for achieving zero carbon aviation, we are putting out work packages to assess battery energy density on fuel cells, electric motor design, internal combustion engines, as I spoke about before. We're interested in combustion and things like flashback for zero carbon fuels like hydrogen, on NOx and on thermoacoustics. We want to understand gas turbine performance and how heat exchangers could potentially have a big effect on that performance. We're interested in liquid hydrogen tank design and validation, and we're also interested in cryogenic systems. We believe that cryogenic systems are a critical enabling technology, but they're also an area where UK competence in aerospace where competence in UK aerospace is very limited. We do believe there's some expertise in the UK actually in areas like gas products, in the space sector, in nuclear fusion and medical imaging, and we're trying actively to engage with companies in those areas to see how they can support zero carbon aviation. But if you have capability in cryogenics, or if you know an organisation that does, we're really keen to hear from you. And these are the 3 areas that we're looking for support on. So one is around hydrogen tank design and validation. The second is around cryogenic systems architecture development. And then the third is on cryogenic equipment technologies. And that last one is about carrying out a state-of-the-art review and assessing the enablers and blockers for application into aviation. So just to sum up, we really want to hear from you, and we especially want to hear from you if you have knowledge and capability which supports our goals. I've put down there 5 areas in case they help trigger people to respond. Think about those technology areas or technology bricks. Are you developing a technology that you think could be critical to realising zero carbon aviation? Could you contribute solutions to some of our integration challenges? Do you have solutions for testing zero carbon systems or for tools that could help us compress the development cycle? Do you want to be part of the future supply chain, or can you just provide us some advice that will help the UK on the FlyZero mission? Please get in touch with us. This is a project for the whole of UK industry and UK aviation, and we want to get the best possible outcome for it. So thank you very much for your time, and I'll pass on now to the next speaker.
My name's Steve Newbury. I'm the academic coordinator for the FlyZero programme. I will give you an update on some of the work that we've been doing over the last few months and explain what our plans are for the rest of 2021. So really the aim of the academic research programme is to support the FlyZero project team with more in-depth, detailed academic research analysis to answer difficult questions that we've got that we need support with to support our kind of programme objectives and decision making in the project, and also we've reached out to academia to secure ideas and solutions to some of the challenges we've got, and to kind of widen our network and bring in new ideas into our project team. So that's the aim. We're really focusing on largely on technical questions, but also there are some commercial questions we have, and sustainability is obviously a core part of our project. So we have specific work packages on sustainability areas, and also looking at kind of more broadly at innovation as well. So over the last few months, we've been engaging with a number of academic research groups, and we've been developing statements of work in parallel. and these we're beginning to now talk to academia about, and we're just starting to actually procure. We've just begun procuring our first pieces of research. So the total budget for the academic piece of work this year is £1 million. So we'll be procuring a number of different small discrete pieces of work to different institutions around the UK. So this research activity is being promoted either through FlyZero, through myself, through events like we're talking here today, or also through the UK ARC as well. So one of the requirements for our research is that research institutions need to sign up to a research contract, which we will share with people that are working with us. And as I said, all research needs to be completed by the end of 2021. So in terms of the organisations that we've already engaged with, we've been actively engaging with quite a large number of university research groups across the country. There's varying levels of sort of engagements. We've had university come in and present their capabilities to us. Many have done that, so thank you to those listening today that have done that. So we've got more planned over the next few weeks. And then we've also we're starting to kind of work in a lot more detail with some groups where we're looking to just finalise kind of statements of work and to procure research. The time frame of this project is very tight, so we're really having to kind of spend a lot of time really focusing on our this engagement, both from a technical and project statement of work perspective, but also on the contracts, working with the contracts officers as well. So in terms of the sort of timing plan for this year, so since up until kind of April, we've been really busy identifying. We've recruited a new team for FlyZero, and it's the engineers and the technical team have had to figure out exactly what are the priorities that they want to explore with the budget that we've got. So we've now identified around about 30 projects in total, and so there's kind of agreement on that, and we're now kind of pushing forwards with those projects. So there's been a lot of, over the last couple of months, there's been a lot of engagement with research groups, and we're really now working with those groups to assess their ability to support us and to start to put in place actual contracts to make these things actually make these activities happen. So that's the real focus at the moment, is procuring the research, and that's my job to make sure that happens. And then as we start to procure the research, we'll be then helping to manage the research programs up through to the end of the year. And we've got a lot of experience in the FlyZero team, and a lot of people that have had experience working with academia before. So we hope that it's a very collaborative experience, and we're very keen to kind of work with academia as we kind of support and with these projects as we move forwards. And then everything needs to be completed by the end of the year. So in terms of the actual research briefs that we've been developing, here's just an example of sort of a top 10, if you like, of just to give you a sense of the types of research tasks that we are interested in, and some of these things have come from the teams within the FlyZero project, and then other things have also come from research groups presenting to the FlyZero team, and then through discussion we've helped to refine specific statements of work. But as you can see, there's a lot of focus on new fuels. That's a major part of FlyZero's aim, is to deliver zero carbon flight. So no surprise that that drives the requirement for a lot of innovation in the fuel system. So through the sort of engagements we've had so far, so for what I've really learned over the last couple of months of working in this role is that the team that we've built within FlyZero is actually, there's quite a lot of people in our team that have experience working with academia, so that's really helpful for me. And then also through engagement, we've got really good engagement with academics, and they've been really keen to engage with us on the project. So and I think they also recognise that the two-way kind of learning is what we've built a very experienced team with a lot of knowledge, that's been seconded from lots of different companies. So I think that's also very interesting to them. One of my sort of concerns previously was around the capability and access to researchers to be able to support our project, because it's very short term and we're giving people quite short notice. But actually, I'm pretty confident that there is capacity within the academic research community to support our program. In terms of in practice, the types of people that we're likely to be working with, we're getting support from some senior academics, but also from PhD students or postdocs or people doing MSCs. As a variety of different sort of resources that are supporting our project, and we're promoting our opportunities kind of directly, but also through the UK ARC. So they are also, they're also aware of what we're doing and can help to promote our sort of research aims. So how to get involved? Feel free to reach out to me. We're very keen for research groups that are interested in our project to come in and present to us. So I can certainly arrange that, and then we can then work together around specific research briefs. So if you're not already involved and you'd like to be, then do get in touch with us, and we look forward to sharing more about what we're doing in FlyZero. Thanks very much.
Right, thank you to all our presenters who now join us together on this Q&A session. So we're all here together. If you haven't already had a chance to ask your question using the QR code on the right, or visit slido.com and entering the event code 098956, please do. Now, Naresh, I'm going to hand over to you, and you can now put one of those questions to us.
Thank you very much indeed, Chris. I'm really encouraged by the number of questions and the depth of these questions that have been put forward by the audience today. So really looking forward to answering some and also passing them on to others to answer. So the first one says, how many international team members are bringing in talent into the FlyZero team? If I could pass that on to Chris, please.
Thank you, Naresh. And thank you, whoever asked that question. Really good question. So we are using a range of people on FlyZero from a mixture of countries and races. And we have a very mixed group of people who we've all sort of hired through a secondee process through their existing businesses. The only criteria for FlyZero is they must have the right to work in the UK to be on FlyZero. And we're certainly clearly looking for some other expertise out there, and we are trying to engage with those global businesses that might have some support that could help FlyZero on its challenge. But it's quite a difficult environment at the moment with COVID and that to actually get face-to-face conversations with some of these global companies. Thanks, Naresh.
Thank you, Chris. The next question, there's two parts to it. First part, are FlyZero looking at wide-body concepts? I'll pass that on to Dave Devaney, if I may. And the second part of this question is, why is sustainable aviation fuel not a technology brick? And I'll try and pick that up afterwards. David?
Thanks, Naresh. So are we looking at wide-body concepts? The short answer is potentially. What we're doing at this stage, as I said in the presentation, is setting up a different series of feature combinations in the Scout aircraft to look at where the technology will drive us. The starting point, as Chris said earlier, for the project was to look at the regional to narrow body space. But if the findings from the studies we've done so far point us to the fact that wide body is a feasible option for a zero carbon solution, then we will expand the scope to look at that. We haven't made any firm decisions on what's in or out of scope at this stage, and we'll continue to learn as we go through. Just to touch briefly before I hand back to Naresh on why SAF isn't a technology brick, at the moment, it's felt that SAF isn't concept dependent. So SAF is an option regardless of configuration. And so actually you could apply that to almost any aircraft. So we're likely to use that as a baseline for comparison, but it's not in the active consideration on FlyZero at the moment.
Thanks, David. Yeah, just to add a point from a sustainability perspective on sustainable aviation fuels, clearly they have a huge role to play in the roadmap to zero carbon flight, especially for the long haul journeys. But really the aim at FlyZero is to explore new and revolutionary energy sources, production and the propulsion systems, which we believe will eliminate carbon emissions and power the next generation of aircraft. So our focus is very much on zero carbon fuels and energy sources that we can lend our investigation to. Okay, the next question, given the long lifetime of aircraft and capital intensity, 60% of aircraft flying in 2050 will be today's technology. Do we need cash for clunkers? ? Can I pass that on to Katie, please?
Thanks, Naresh. I mean, government incentivization of the changeover in technology is definitely something that we need to think about. And actually, Mark's team, in case he wants to add in, is doing a piece of work around that. On my side, we're looking to engage with the automotive sector because they're further ahead of aviation in their decarbonisation journey, and we want to understand how the dynamic happens between the government and between the automotive sector in different places around the world, and what the aviation sector can learn in terms of navigating that journey, doing it better, how it impacted supply chains and development cycles.
Thanks, Katie. Mark, would you like to add something?
Yeah, just to follow on from what Katie said, clearly what we are interested in, what we're looking to do is actually do a piece of work on the impact of legislation, what that could actually do, how could that help us collectively on the sustainability journey.
Yeah, could I add something Mark as well, Naresh?
Of course, Chris.
Yeah, I think I'd just like to add that, there's clearly a big economical case here of what to do in terms of changing the aerospace aviation products that are flying today. And as the questionnaire has clearly identified, one of those cases is going to be how do you make it change very rapidly as opposed to an evolution-based approach? And really, part of what FlyZero can see is we need to have a revolutionary approach in terms of the aircraft that are flying and how can they be swapped out either to some form of sustainable fuel until they become unusable, or maybe even legislation which would eliminate certain vehicles to fly. And those are some of the challenges that governments around the globe are going to have to face.
Thank you, Chris. There's a couple of questions on a common theme here about FlyZero and similar programs elsewhere, so I'll pick one of them. Are other countries running similar projects to FlyZero? How far on are they, and will we collaborate with them? Chris?
Yeah, so what we see in FlyZero is a lot of the technology we're looking at is very new and is not really defined in the facts and figures for those technologies. And what we're trying to do is analyze those technologies and say, how can you apply them to aviation? And this is not an easy question. It's a very complicated question, because not only does it include the vehicle, it includes the infrastructure needed to supply whatever that fuel is to the vehicle, as well as how would you operate that vehicle at the airport and in the air, and also how will the airlines operate that vehicle. So it's a multi-complex question we're trying to solve. I don't think that FlyZero is lagging behind other industries around the globe in terms of looking at this. There are certain key expertise around the globe, which varies in capability and quality and skills. And certainly there are areas where we haven't got as much capability as some of the other global countries. Our plan is to develop our solutions so that we can then engage with those global countries and actually hopefully then build a stronger solution and anchor some of that technology in the UK. Thanks, Naresh.
Thank you, Chris. So a related question, I guess. How is intellectual property being managed through the work package activity? If I could ask Katie.
Yes, hello. So we've got a number of routes for engagement on FlyZero, and the work packages is one of them. Steve Newbury also spoke about the academic program, which is for more fundamental research questions. But the supplier agreement is actually on the website. So if you go to ATI's FlyZero website and look at work packages, then there's a link to the supply agreement, and the IP terms are within that. So yeah, please go and have a look. But if for whatever reason you are not successful in becoming part of FlyZero through that route, we're still very keen to hear people's voices. We'll be running events throughout the year, and please just reach out and get in touch. We need this to be an involved, inclusive program. It's about creating a sense of mission for the entire of the UK.
Thank you very much indeed, Katie. Another question, one that I will take personally. If we switch to hydrogen, we will be releasing 10 times the amount of water per ton of fuel. How do we reconcile overall water management? An excellent question. The last thing we want to do in FlyZero is swap one problem for another. In eliminating CO2, we certainly do not want to create a problem that might manifest itself from a higher amount of water that we might be emitting. And although at face value, people might not think of water as a problem, if you're emitting water at altitude as a vapor, it can have two potential effects. One is the formation of condensation trails, which could lead to the formation of cirrus clouds and hence global warming. The other potential risk is that if you're emitting water above the tropopause in the stratosphere, that also can have a warming effect. There are also some effects where water can have a negative warming or cooling effect, but that depends on chemical reactions between the water and other species that might be in the atmosphere. So this is quite a complicated problem to solve. we are undertaking a extensive program with Steve Newbury's help with academia, looking at precisely this issue about the potential impact of water and what effect it may have on global warming. So although we don't think that this is going to be a major issue that we can't overcome, it is certainly in our sights, and we intend to manage it very carefully. Okay. Another question. Are you working with the UK CAA or others on any regulatory developments? Could I pass that one on to Mark?
You can. I think Dave would be a good person to answer that. But yes, we
David,
are.
you want to do that one?
We are working with them. Dave, do you want to answer that question, given you're taking the
lead?
So yes, we are, absolutely. We see this as a good opportunity both to work closely with the regulator on the new technology and also help their understanding. So we've set up a close working relationship with the CAA to look at the different aspects of the technology that we're looking at and where some of the risk areas may be and how that may drive the design. So, you may find if you're looking at aspects such as liquid hydrogen, the aircraft design is driven in quite a different direction to what we'd be used to seeing, partly because of the safety considerations. We are also working with the CAA on other aspects because the CAA do have a remit to look at airspace and airport management as well. So we are considering those aspects of alternative fuels, and we'll be working closely with them throughout the rest of the programme.
Thank you, David. There's one here definitely for Mark Howard. This all seems very aircraft design focused. Are FlyZero looking at airspace design too, and will they be funding it?
So thanks, Naresh, for the question. Yeah, so absolutely looking at the airspace design, looking at how the system, the overall system of systems works together, looking at how we can develop sustainable operations, looking at the things like contrail avoidance, the perfect flight, the optimized flight paths, and ultimately how do you actually maximize capacity in the air whilst minimizing sustainability. So that is some modeling that we're looking to do. We are looking at putting some work package out on that kind of topic area, dependent on what the aircraft concepts that come out. So yes, we will be doing a little bit of work in that area.
If I could add to that as well, please, Naresh. I think it's also worth pointing out that there's a natural synergy between other activities that are already going on, like the Future Flight Challenge, which is part of the Innovate UK ongoing activities to look at the future of aviation. And so there are a range of activities that FlyZero is complementary to and will be collaborating with those pre-existing activities.
Yeah, and maybe just to finally close off that point, we have been discussing with some such collaborations already with some of those potential collaborators.
Thank you very much indeed, Mark. I'm going to pick a question here, partly to bring in one of our other speakers, Steve Newbury, and I hope I get it right. Fraunhofer Institute of Manufacturing has developed a power paste for hydrogen storage, which is safe and has high power density. Has this been looked at? And really from an academia perspective, I know Steve's been doing a lot of work in terms of identifying the latest capability that we've been tapping into.
So it would, as far as I'm aware, our propulsion team, we've got a small propulsion team, and they have been looking at a whole range of different technology innovations from obviously in the UK, but also overseas as well. That specific opportunity, I'm not too sure. I'd need to check with the propulsion team, but maybe if the person that raised the question could perhaps signpost us to the piece of research, that would be really helpful, and we can follow up.
Brilliant. Thanks, Steve. I've got a related question actually on the academic side. Where are the academic statements of work advertised? Are they open to different universities submitting proposals?
Yeah, so we're promoting the statements of work both through the UK ARC community. So if any universities that are listening in are members of the UK ARC, then you can access the statements of work through them. Also linked through our own the FlyZero pages on the ATI website as well, or you can also contact me directly on the email that I gave out during the presentation. So yeah, through all those routes really. And as I said, our focus is really to procure our kind of research work packages over the next couple of months to deliver the findings that we need before the end of the year.
Thank you very much indeed, Steve. Okay, next question. This is a provocative one. Should short-haul flights be reduced or banned, especially when other modes of transport, such as traveling by trains, is possible? May I pass that on to the project director? Chris.
Thank you, Naresh. I'm a strong advocate of flying, and so therefore my simple answer is we should continue to fly. And what we need to do is fly in an environmentally protected way, which is why we're focused on zero carbon emissions. And if we can get to those solutions, which are not easy, they're hard. And part of the reason FlyZero is looking at this is because, this is a really difficult question to answer. How do we achieve flight without causing a lot of carbon emissions into the atmosphere? And we know today that battery operated vehicles can do this over short ranges, and that's fantastic. What we're trying to do is push it a little bit further. So instead of 100 or 150 nautical miles, we're looking at 250, 300 nautical miles. And that's where the challenge initially starts and grows as you go to 1,500 nautical miles. But we are doing this for the benefit of the global community, because somebody needs to understand the facts and figures that are associated with doing this so that we can determine what is the most effective way to get there. Because without a doubt, we'll be on a journey here and taking steps at a time to get from where we are today with emitting 70, 80% carbon into the atmosphere to zero. And that's our goal. That's our objective.
Thank you very much indeed, Chris. Thank you. This is quite an appropriate one. Is there a role for startups and entrepreneurial talent within the FlyZero program? Katie?
Yes, so there's probably two routes to engage during the project. The first is the work packages, which we spoke about earlier. So please go and see if your organisation could bid in to deliver those. But if you imagine that FlyZero is all about creating the roadmaps and forward activity in the UK for the next decade, we are very keen to make sure that as part of that forward journey, we are promoting and encouraging a vibrant startup and entrepreneurial community within aerospace against the existing strength that we have in the UK in terms of incumbents. We see that those two things working alongside will kind of create the fastest route to zero carbon aviation, with the agility of smaller companies, the capacity of larger companies. And we really want to understand how the programme needs to evolve in order to accommodate those two separate groups. So yes, if you are a startup, please get in contact with us.
And can I just add to Katie's fine words is that, what we see in FlyZero is some of the technologies we need don't actually sit within the aerospace community in the UK or in any aerospace community. And what we see is we need some revised or new or emerging supply chains that don't actually have any aerospace equipment today, but could. And that's part of what we're trying to find out the answers to. And as Katie rightly said, create those industrial roadmaps. So yes, please talk to us.
Thank you, Chris. Thanks, Katie. There's one that I will pick up. The question is, what is the plan to address the fact that only 3% of hydrogen produced is green hydrogen? I think this is a really, really very important question. I mean, hydrogen is one of the fuels that we're looking at very, very seriously. When I look at the electricity mix here in the UK, as recently as 2018, we were producing around 50% of our electricity in this country from very low carbon sources. And I'm talking about wind turbines, solar, nuclear, bio, as well as other very low carbon sources of electricity. So the proportion of low carbon electricity has been ramped up and is increasing extremely rapidly. If you look at the detailed sixth carbon budget report from the Climate Change Committee, in there you will find a couple of charts that detail the sort of energy sources that are going to come on stream between today and 2050. And hydrogen actually plays a very significant proportion of that. Now, whether that changes and gets bigger between now and 2050, that will depend on how many sectors actually adopt hydrogen as a particular fuel. So I do actually see that hydrogen, particularly from green sources, is likely to ramp up depending upon demand as we go through the next few decades. So it's certainly one that we need to stay very close to, given the prospects that it offers. Okay. Here's an interesting one. How is FlyZero enduring independence, given members are seconded in from organizations with potentially biased opinions? Extremely provocative. Chris.
Thanks, Naresh. Without a doubt, we have a large group of secondees from many different industries. But what I can say to you is they all come into FlyZero with their own thoughts and how to address the problem we're all looking at. Their own industries are focused on this problem, but we're trying to work as a complete independence. So we have a governance board that's checking that we're thinking openly about the topics, and we are checking on a regular basis that we are. I myself am an independent, and I will push all of my leadership team to make sure that we look at all, or under every rock, I should say, to make sure that we are chasing all the solutions. Because what we're really looking to do is challenge every paradigm that's out there today against aviation and try and find what do we think are the logical solutions. But at the same time, trying not to be unrealistic in that we don't consider the economic facts as we try and do this. And so it's a bit of a challenge to how we manage that. But I think we're doing an excellent job at the moment. And I have to say that the people in FlyZero are incredibly enthusiastic and energetic to find the solution to the problem that I posed them all, which is how do we get to zero carbon emission aircraft vehicles and how do we operate them? So they're all focused on that, and that does drive the whole team.
Thank you very much indeed, Chris. Thank you. This next question has been quite popular with a number of the attendees. Where is the industrial strategy element of this? How will this program help to grow the UK's share of next generation single aisle, for example? Katie?
Thanks, Naresh. I think our aim is to understand how the market might evolve and also the UK's not strengths and weaknesses, but where the UK can play to win, so that then we can inform the relevant stakeholders, whether that's industry themselves or government in its negotiations and positioning globally in trade agreements about where we think the UK should be acting. So industrial strategy is a important output of the programme. I'm responsible for it. I need input from as many of you as possible. And it's something that we'll be engaging on very heavily in the coming months. The first part of the programme has really been about fact-finding technically. And as we progress, and particularly as we get to the stage where we've understood the priority technologies and we have our concept aircraft around July, we'll be consulting increasingly in depth on what's the route forward for industry, what support is needed from government, what can private investment do as well. So yes, please get in touch with us.
Thanks, Katie. Anybody else would like to add to that? Okay, thanks. Can you elaborate on what you are doing on the safety requirement work stream, i.e. to ensure equivalent or better levels of safety? David?
So I'm not quite sure this is the right forum to go into too much detail. I think I would summarise the approach we're taking as making sure that we're considering safety from the start, looking at the regulations as they are today with respect to the technology ideas and scout configurations that we're coming up with, and looking at where some of those limitations might be. Even since the last generation of single-aisle aircraft were designed, the regulations have moved on. So a good example would be the uncontained engine failure and how that might mean the location of propulsors or engines relative to fuel tanks may need to be positioned. So really it's just a stepwise approach to make sure that we're factoring these things in. We recognise that within the 12-month project, we can't address all of the risks, but actually, as we've alluded to throughout the earlier presentations, that will form some of the activity that needs to follow on, both in terms of validation of technologies and also safety aspects as we progress into the future and understand the challenges, opportunities, and those associated effects better.
Thank you very much indeed, David. Thank you. We've got time for perhaps one, maybe two questions. Let me pick this one for myself. Why not reducing NOx to zero as well as carbon? Well, look, in my talk, I did explain that although the primary aim for FlyZero is to achieve zero carbon emission aircraft to enter service in 2030, we're not going to ignore all of the other aspects of aviation by way of emissions, including NOx, particulate matter in terms of air quality, as well as noise. So NOx is another aspect that we do plan to look at and are looking at because the choice of the fuel that we make at the end of the day or recommend and the energy systems will determine the level of NOx that may be generated. This is another area where technology can lend itself to further improvements as we go forward. And if you recall from my briefing, we are seeking to make sure that the concepts we put forward for entry into service by 2030, we want to achieve at least a 25% reduction in NOx. So we're not going to leave any stone unturned. We're looking at all aspects of sustainability in the work that we have planned out. Okay. Let me see if we can squeeze another one in. Chris mentioned this is backed by government. Are there any other government funding this project other than the UK? If so, who are they? Chris?
Yeah. So as of today, FlyZero is funded by the UK government, 100% 100%, and they are supporting the work we're doing. And we have been given a grant offer letter, which is what we're delivering against. And the team is focused on how to deliver that. Our plan is deliver an initial sort of outline report by the end of the year and to issue a final report in February of 2022, which will detail our roadmaps, our technical roadmaps, our industrial gaps and capabilities roadmap, our skills roadmap, and also our economic models of how we could see FlyZero being applied to the aviation industry. I think one of our desires is to actually drive FlyZero to carry on and develop some of the future technologies and hardware needed to actually make it real.
Thank you very much indeed, Chris. Well, look, I'd like to draw the Q's and A's to a close here, given where we are in terms of time. Can I please thank all audience members for submitting such a comprehensive set of questions? My sincere apologies to a handful of you where I might not have been able to get to your question, but please, outside of today's session, keep talking to us. And last but not least, I'd like to thank the panel members for their very comprehensive answers. Thank you. Let me hand you over back to Chris.
Thank you, Naresh, for organising the Q&A. And thanks, everyone, for joining our webinar this afternoon. I hope you learned about FlyZero and what our mission is and will support us as we go through the next 8 or 9 months of this activity. We're very keen to get your support, but also to work with the communities to make sure that the information we can create and develop is going to support the UK going forward in what is a global industry in the aviation world. So we really do look forward to working with you on our shared mission. And, you know, we chose to do zero carbon emissions because in this decade, it's not because it's easy to do it, but because it's hard and somebody needs to get hold of the understanding of the facts and figures to make sure we can determine where this can actually make a difference to the global climate that we see going on a daily basis. So please do get in touch by visiting our website, which is ati.org.uk, emailing flyzero@ati.org.uk, or on Twitter at UK Aero Institute. And again, thank you for listening, and we look forward to meeting you all again in the near future. Thank you, and thank you, team.